So what we're going to do today is learn how to convert one thing to something else, one unit to a different unit in chemistry. Is one of the most central things to understanding how to do the math of chemistry is being able to change one thing to the other. You can do it lots of different ways. If you're really good at math, you're probably going to say that I'm taking extra steps today or I'm doing extra things. But I guarantee you later in the year when things get more complicated, you're going to wish that you had kind of learned the way that we did it right here. Okay, so let's look at an example here. So we use metric system in chemistry because the whole world uses metric system in science. So that's like, let's start with something easy, and that's length. Okay, so what did anybody know what the normal metric measurement for length is?
Centimeters, meters.
Very good. And let's use the first two you said. You said centimeters and meters. Okay, so for every 1 meter, you know how many centimeters there are?
No.
Almost.
100.
Centi, like a century, 100.
Oh, yeah.
Okay? So if somebody said, I want to travel, or I want to walk 337 meters. Okay? And somebody said, well, I want to know how much that is in centimeters. Like I said, most of you guys can probably figure out that relatively simple math.
Yeah.
But I want you to understand, I want you to start learning how to do it in my way, because I'm going to show you how it can help you out when things get more complicated. Okay? So the first thing that you do is you recognize what you got and you recognize what you want. I got meters, I want centimeters. Always the first step in any of these problems is to write down exactly what you have. Now in math class, if you wrote down exactly what you have, you would just write down the number. But in chemistry class, we can't just have a number. You also need the unit. So I'm not going to just write down 337 because I don't just have 337. I have 337 meters. Okay? Then I'm going to draw my conversion tool. Okay? Now, this is something that you need to get used to drawing in this class because we're going to use it a bunch. And it's a parentheses with a fraction in it. And give yourself plenty of room. Always err on the side of giving yourself plenty of room when you draw it. Because a fraction can do lots of interesting math things. Okay? So what we're going to do now is we're going to say, I have meters. Do I want meters?
No.
No. If you want to get rid of something in math class, we talked about it yesterday. How can you eliminate something when dealing with a fraction?
Multiply.
If you have a fraction, how can I get rid of something? If it's where?
On top.
And
On bottom.
very good. If I can get something on the top of the fraction and on the bottom of the fraction, I can poof it. Okay? So here's kind of a trick question for you. Is that on the top of the fraction or the bottom of the fraction?
Top.
Very good. Because even though that's not, I don't have a little line, everything always is over 1. Excellent, buddy. Everything is over 1. So right now, meters is on the top. So to get rid of it, all I need to do is take meters and put it on the
Bottom.
take what you have and what you don't want and put it on the bottom. And then think, well, what do I want? What do I want?
Centimeters.
Centimeters. Guess where I'm going to put centimeters?
On top.
So that's something I'm going to say throughout this school year. You're going to hear me say it over and over again. You got it and you don't want it, where does it go?
On the bottom.
On the bottom. You got it, you do want it on top. And so now we just need to make this fraction equal 1. How do you make any fraction equal 1?
Put the same number on top.
The same thing on the top and on the bottom. Okay? Now it doesn't necessarily have to be the same number. It just has to be the same equivalence. Do we have an equivalence on the board already between centimeters and meters?
Yeah.
What's my number?
337. Wait, 100.
100 what?
Centimeters.
100 centimeters. Bam, there it is. And how many meters?
337.
Nope. It doesn't say 100 centimeters equals 337 meters. What does it say?
One.
It says 100 centimeters equals 1 meter. So this fraction right here equals 1. Because 100 centimeters is exactly the same as 1 meter. What happens when you multiply something times 1?
Stay the same.
You're not changing it. So what this is allowing us to do is I'm not changing what I got. The only thing I'm changing is I have meters on the top and meters on the bottom, so I can poof them, and that'll leave me with just centimeters. So I'm changing my unit without changing what I'm talking about, which is what the goal of doing this is. Okay? So hook me up with some math real quick. You could probably do this without a calculator, but you got one just in case you need it. I'm going to say 337. What's my math right here? 337 what?
337 meters.
No, don't worry about that. Just the numbers now.
337 on the bottom. Right.
Just tell me what's the only math I have on the board right here?
Division.
Nope, there is not a division on the board. Let me explain why. What is the only number on the bottom of the fraction?
1.
Okay, I used to say I was going to put a sign up in my room that says life is too short to divide by 1. Because what are you doing when you're dividing by 1? What is 4,028 divided by 1?
4,028.
What is the known divided by 1? The known. Okay, so life is too short to divide by 1. I don't even see a division problem up there because the only thing under the fraction is 1. Poof, I don't even see division. The only math up there on the board
Multiplication.
is multiplication. 337
Times 100.
times 100. And now, if you probably know the math trick about that, to multiply times 100, all you have to do is what?
Add zeros.
Add 2 zeros. Very good. And then throw in my comma there for the thousand spot. I have 33,700. Now, if this was a test and you put that as the answer, you did it right, but I'm going to say minus 1 point.
So you didn't put centimeters.
I didn't put the unit, which is, good job, centimeters. Excellent. Now, like I said, you guys could probably have figured that out a long time ago without writing all that extra stuff. But this tool helps you get where you need to go. Make sense? All right, let's try a different one. Questions on what I have on the board? Martin, you with me? Stick with me, buddy. All right, so let's try a different one. Let's say that you buy a Mountain Dew. And Mountain Dew is about 456 milliliters.
How do you know that off the top of your head?
That's like a normal 20, because
Chemistry teacher.
in the United States, we do ounces instead of liters. 20 ounce Mountain Dew is about that much milliliters. I think, I might be wrong, but I'm pretty sure it's about that much milliliters. But 456 milliliters, and I want to know how many liters that is. Okay? So,
It's 591 milliliters.
see, I was just coming up. That's the thing about teaching chemistry. You can make up numbers off the top of your head. So I did. Thank you, though, man. So I think 16 ounce might be 456. I don't know. Don't worry about it. Rolling on. Okay? But 456 equals how many liters? So I'm going to start off with the same step I started off with before. Write down exactly what you have. What is exactly what I have?
456 milliliters.
456 milliliters. Don't just write down the number, because that's the biggest mistake I see. Whenever people start practicing this on their own, I come around and they have this problem in front of them and they've written that and they say, well, I don't know what to do next. You don't know what to do next because you don't have these things that are guiding you to what to do next. Because now we remember our next step, which is draw our conversion tool. I got milliliters. I don't want them. Where do they go?
On the bottom.
What do I want?
Liters.
Liters. Now, I haven't told you the conversion for this. I'm going to put a big chart up on Canvas that deals with conversions. I don't ever need you to memorize your conversions, but just kind of things like milli and centi, you might want to have a good work on. Centi is 100, milli is,
A milli? Wait.
not, that would make sense, wouldn't it? But it's not. Milli is, so 1 liter equals 1,000 milliliters. Okay? Milliliters, liters. Where's my 1,000 going?
On the bottom.
On the bottom. And how many liters?
One.
1. Now, what's the only math on the board?
Multiplication.
No multiplication this time. Because what am I multiplying by? Same thing as dividing, right? If you're multiplying by 1, you just wasted buttons on the calculator because you know what anything multiplied times 1 is, right? And so the only math on the board this time is division, because the only non-1 number is on the bottom. So you're going to say 456.
5 by 1,000.
Hook me up. I'm going to let you use your calculator for this one. You could probably figure it out without a calculator, but I'm going to let you use your calculator.
Math is confusing.
Well, stop me if I lose you, brother.
0.456.
0.456. Very good. Liters. Go ahead. One of my goals in chemistry class is to get rid of wrinkled foreheads. So what's the problem?
Mine got 2.19.
So I think you probably went backwards. You probably did 1,000 divided by 456.
Thank you. That's how you always.
Yep. You read a book from left to right or right to left?
Actually,
No. You with me? Do you understand? That's why I like doing it like this, because it's like reading a book. 456 divided by 1,000.
You read them
Okay.
both ways.
No.
Technically, there's Japanese books. Like, for example, I have a series of Yu-Gi-Oh books at my house that you read left to right.
You speaking Japanese?
They're spoken in English too.
In this class, we don't speak no Japanese. You with me? Okay? Much love to the people in Japan that go backwards, but in this class, we're going to go from left to right. Keep life simple. Don't let it confuse you. You with me?
I got it.
Okay? You feel good? All right. Let's roll on. Any questions? Everybody feeling good? Okay.
I'm lost, but I'll find
No,
out.
hey, look, but you got to, as soon as I do something you don't see why, you got to speak up. Okay? Same thing with folks on the Zoom. Holler out if I need you. I think I just heard a thing.
Find if I wish.
See if anybody needs to be let on here.
Do you know, do we?
But if you're ever on the Zoom and you got a question, don't hesitate to holler out. All right? Rolling on. All right. So let's take it a step further. Let's say I want to get to Aden. We talked about going to Aden yesterday. We talked about the distance. And let's say the distance to Aden is, we said, I think 4 miles, 5 miles, something
6
like
miles.
that. 6 miles. Let's say it's 10 kilometers. Okay? Kilometers a little bit shorter than a mile. So let's say 10 kilometers. Okay? And instead of a person walking, we're dealing with a caterpillar making its way to Aden. And caterpillars don't move in kilometers. Caterpillars don't think in kilometers. Caterpillars think in centimeters. Okay? Well, we have a problem here, because I don't know the number that takes me directly from kilometers to centimeters. So I'm going to need to go ahead. You probably could. You could figure it out, but that's beside the point of what I'm trying to get at. I know that there's, for every 1 kilometer, there's 1,000 meters. And I know for every 1 meter, there's 100 centimeters. But I don't know how many centimeters there are in a kilometer, just because you're not supposed to know that. So here we go. We're going to start off the exact same way we did before. We're going to write down exactly what we have, which is 10 kilometers. And I'm going to keep on rolling. I'm going to write down exactly what I need, which is my conversion tool. And I'm going to ask the same question. What do I have? Do I want it? Where does it go? Now, here's where my question gets a little bit different. What do I want? Can I go straight from kilometers to centimeters? No. So first I need to change kilometers to meters. And we're going to use our numbers up there. How many kilometers?
1.
And how many meters?
1,000.
All right. Now, if I stop there, what would my answer be in?
1,000.
What would my answer be in? What units?
Yeah,
Meters.
meters.
Is that what I want?
No, you want centimeters.
And so anytime you got something that you don't want, you need your conversion tool. So I got something I don't want. I'm going to put another conversion up there. Everybody feel good?
Mm-hmm.
I got meters. I don't want meters. Where do they go?
20 bottom.
What do I want?
Centimeters.
All right. How many meters?
1.
And how many centimeters?
100.
What's my math?
Multiplication.
Just multiplication, because there are no non-1 numbers where?
On the top.
There are no non-1 numbers where?
Under
Under the fraction. Since there are no non-1 numbers under the fraction, all we're doing is multiplying. 10 times 1,000 times 100 should be a pretty big number.
100,000. 100,000 centimeters.
Very good. Feeling it? All right. Let's try one more. I'm going to see you guys again in 23, let's say 23 hours. I'm going to see you guys again, and let's make it the math fun. I'm going to see you guys again in 23.2 hours. And because I love you guys so much, I'm going to count every second that I'm away from you. So I want to know how many seconds that is. Now these, you know the conversions for, so I'm not going to write down the conversions. Okay? We're going to write down what first?
Well, what we have.
Exactly what we have, which is?
23.2 hours.
I'm going to just use H to shorten hours. What am I going to draw?
Conversion.
Conversion. What do I have?
Hours.
What, do I want them?
No.
Where do they go? Now, I don't know how many seconds are in an hour. I don't.
Which how many minutes are in an hour?
But I do know how many minutes are in an hour. All right, now I didn't give you the conversion. Let's see if we can figure out how to do this. What number's going where?
1's on the bottom and 60's on the top.
Let's stop there and make sure everybody's with me. Leah, Martin, Matthew. Matthew, right? I'm sorry. Okay. Got another Matthew in another class and making sure I'm good.
Look.
This is what Josh said do. Oh, dang, my bad. You see why?
Yeah, because 60 minutes is an hour.
And they're the same thing. You want to make, every time you make a fraction, you want to make it equal 1. This and this are the same. This fraction equals 1. I don't want minutes. What do I need to do?
Second, you want seconds.
So you make another thing.
Minutes.
And you put minutes on the bottom.
And
And
then
then you put seconds.
the seconds on the top.
So you put 1 on the bottom and 60 on the top.
Same thing. There are 60 seconds in 1 minute. Only math I got.
Multiplication.
What am I going to do?
Multiply all the top numbers.
23.2 times 60 times 60. I definitely need a calculator for that. Double check, make sure he's right.
Yep.
All right. 83,520 seconds if you count every second from now to the time we see you again. Make sense? I told you that was the last one. The math was the same, so I do want to do one more because I want to make one that the math is different on. Let me think of one I can figure out here. I'm gonna make this one up. This is one that we're gonna do way near the end of chemistry class, but I'm gonna kind of guide you through this one, okay? So let's say you have hydrogen gas combining with oxygen gas to make water. First thing you gotta do is balance that chemical equation. 2 hydrogens, I'm good. 2 oxygen, 1 oxygen. I gotta fix that, so I'm gonna get 2 molecules of water. That gives me 2 oxygens, but it also gives me 4 hydrogens. Gotta fix that. That's 4 hydrogens. Don't stress out on that. Look. We're gonna learn that later. Don't stress. Don't stress. Don't stress. Don't stress. Don't stress. Okay? I'm gonna tell you that you have, I wanna make 5 liters of water. I wanna make 5 liters of water, and I have, let's make the number easy. No, let's not make it easy. Screw it. I have 10 grams. No, I want to know how many grams of oxygen. How many grams of oxygen I need to make 5 liters of water. What am I going to write down first?
What you have?
Which is?
Hydrogen and oxygen. Wait,
5
liters.
liters. But it's not just, I got more than one thing up there, so I need to be more specific. 5 liters
Of water.
of water. H2O.
Spirits.
What's up? Just stick with me. Okay? I don't want liters of water.
You put on the bottom. No, you put on the bottom.
Now, this is something that you don't know. Don't stress. I love you. I'm going to change liters into moles. You don't know about it. We're going to talk about it later. Moles of water.
That's how much stuff you have.
How much stuff you have. For every 1 mole of no matter what you're talking about, the box that this is on, Leah can see it, but you guys can't. Leah, see what that number is on that box? That number right here, baby. Right where my camera is. You see it? 22.4 liters, see it? That box represents a mole of gas. 22.4 liters. Okay? That gets me to moles. I don't want moles. Moles of water on the bottom. And I'm going to go moles of water to moles of oxygen. Moles of oxygen on the top. Okay? Now, the comparison to water to oxygen is for every 1 piece of water, because a blank is 1. For every 1 piece of water, I have how many pieces of, for every 1 piece of oxygen, I have 2 pieces of water. So for every 1 mole of oxygen, I have 2 pieces of water. Okay? I don't want moles though, I want grams. So moles of oxygen on the bottom, grams of oxygen on top. In 1 mole of oxygen, O2, now Leah, what's the red number under O? 15.999, we might as well say 16. You feel good? Everybody feel good? Okay, we're gonna say there's 16 grams in every 1 atom of oxygen, but look how many atoms of oxygen I have.
2.
So instead of 16 grams, I'm gonna say 32 grams. Now we got some math. Because now we have what math on the board?
We have division. Wait.
Keep talking.
We have division.
Keep talking.
Multiplication.
We have multiplication
and division.
and division. You see me?
Yeah.
We have multiplication because there's a non-1 number on the top. We have a division because there's non-1 numbers on the bottom. Now we have to be very careful with our PEMDAS here. Everybody remember PEMDAS?
Yeah.
Which comes first?
Parentheses.
Yeah, but I ain't stressing on the PE of the PEMDAS. Which comes first between the 2 things that I have?
Multiplication.
Multiplication comes first. Multiplication comes first, so I'm going to multiply before I divide. I'm going to do all my multiplying before I divide. Now, here's the trick question. This is kind of tough. Let's see if we can stick with me. Anybody know what the first multiplying I'm going to do is?
The first.
5 times 32.
Very good. Very good. 5 times 1, who cares, times 1, who cares, times 32. 5 times 32, hook me up.
160.
I still need to do what?
Divide.
Before I divide, there's another multiplication problem up there.
You have to do
kind of gave you a hint by putting this line here. I did all the multiplying on the top. I need to do my multiplying on the bottom. What is it?
You have to multiply 5 as well.
No, 5's where? We talked about that before.
On top.
5's on top. I'm done with 5. I'm gonna multiply
22.4.
22.4.
Times 2. Times 2. Yeah. 44.8.
Now the last step is my division, which is,
Divide. Okay.
because I have what's on top, bam,
160 divided
and I have what's on the bottom, bam, 160 divided by 44.8.
3.57.
I like hearing it from both people, guys. That's good. 3.57 grams of. So if I take 3.57 grams of oxygen and burn them up in some hydrogen, I can make 5 liters of water. Isn't that cool?
Let's test it.
Okay. Well, there's labs in certain places that they do test it. That's chemistry. That's the soul of chemistry right there. Is how much of this do I need to make a certain amount of this? Make sense? All right, we got some practice work to work on. Thank you guys for joining me. Thank you for joining me in the Zoom. I've been hearing sounds. Is there anybody with a question in the Zoom? I see Daniel there. If you got a question, holler, Daniel, before I'm going to go cut this video off, and then I'll give you a second to holler if you need me.